8th International Physics Olympiad, year 1975, IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Measure me if interested. My email is fred1996@hotmail.com or use Skype name Eduard F1996. Problem number 1. Rotating rod. A rod revolves with a constant angular velocity omega around the vertical axis A. The rod includes a fixed angle of pi over 2 minus alpha with the axis. A body of mass m can glide along the rod. The coefficient of friction is null, equal tangent beta. The angle beta is called friction angle. Question A. Determine the angles alpha under which the body remains at rest and under which the body is in motion if the rod is not rotating. It means omega equals 0. Question B. The rod rotates with a constant angular velocity omega greater than 0. The angle alpha does not change during rotation. Find the condition for the body to remain at rest relative to the rod. You can use the following relations. Eighth International Physics Olympiad, year 1975, IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Measure me if interested. My email is fred1996@hotmail.com or you can use Skype name Eduard F1996. Problem number 2. The focal length f of a thick glass lens in air with a refractive index n, radius curvatures r1 and r2, and the vertices distance d, see the figure, is given by formula f equal this expression. Remark: Ri greater than 0 means that the central curvature point Mi is on the right side of the aerial vertices Si. Ri less than 0 means that the central curvature point Mi is on the left side of the aerial vertices Si, where I equal 1 or 2. For some specific applications, it is required that the focal length is independent from wavelength. Question A. For how many different wavelengths can the same focal length be achieved? Question B. Describe a relation between Ri, where I equal 1 or 2, d, and the refractive index n, for which the required wavelength independence can be fulfilled, and discuss this relation. Sketch possible shapes of lenses and mark the central curvature points M1 and M2. Question C. Prove that for a given plane convex lens, a specific focal length can be achieved by only one wavelength. Question D. State possible parameters of the thick lens for two further cases in which a central focal length can be released for one wavelength only. Take into account the physical and the geometrical circumstances. 8th International Physics Olympiad year 1975 IPHO. I offer private tutoring for physics Olympiad preparation. I currently have openings. Message me if interested. My email is fred1996@hotmail.com, or you can use Skype name Eduard F 1996. Problem number 3. Ions in a magnetic field. A beam of positive ions, charge positive E, of the same and constant mass m, spread from point Q in different directions in the plane of paper. See figure. The ions were accelerated by a voltage U. They are deflected in a uniform magnetic field B that is perpendicular to the plane of paper. The boundaries of the magnetic field are made in a way that the initially diverging ions are focused in point A, QA equal to A. The trajectories of the ions are symmetric to the middle perpendicular on QA. Among different possible boundaries of magnetic fields, a specific type shall be considered in which a continuous magnetic field acts around the middle perpendicular and in which the point Q and A are in the field-free area. Question A. Describe the radius curvature R of the particular path in the magnetic field as a function of the voltage U and the induction B. Question B. Describe the characteristic properties of the particle paths in the setup mentioned above. Question C. Obtain the boundaries of the magnetic field, boundaries by geometrical constructions for the cases R less than A, R equal A, and R greater than A. Question D. Describe the general equation for the boundaries of the magnetic field.